Okay, everybody, here is multiplication properties of exponents. So here I have some exponents and I am multiplying them. Now the first property that we're going to talk about is what does it mean when we're multiplying exponents, okay? So here what we have is 2 squared times 2 to the third. And remember, an exponent just means, or power just means that you're taking the base and you're multiplying it by itself, the exponent number of times. So 2 squared would be 2 times 2. So this would be 2 squared, right? Times, because we're multiplying right here, 2 to the third, that would be 2 times 2 times 2. So here's 2 cubed. Okay, what does this come out to? Well, this is going to be 2 to the fifth, right? Because there's 1, 2, 3, 4, 5. It's 2 multiplied by itself. How many times? 5 times, so 2 to the fifth. So essentially what we're getting is the following. 2 squared times 2 cubed is equal to something with 2 to the fifth as a result. What's going on? Well, how do I get 5? The bases stay the same. How do I get 5 from 2 and 3? Well, obviously, I am adding 2 plus 3, and that gives me 5. Okay, so this gives us the following rule for multiplying powers with the same base. Now, this only works on powers with the same base. Okay? So for every non-zero number, a, and integers m and n, a to the m times a to the n, so notice these have the same base, a, that equals a to the m plus n. So essentially what you're doing is you add the exponents. So when you multiply powers with the same base, you are adding the exponents. Okay, and again, this is with the same base. For example, 3 to the fifth times 3 to the fourth, that is going to be 3 to the 5 plus 4, and you probably remember this, which is going to be 3 to the ninth. Okay, and then you could evaluate that if you wanted to. What is that? You can throw it in your calculator. H squared times h to the ninth, that is going to be h to, again, same base, 2 plus 9, or h to the 11th. Okay, so as long as they have the same base, you just add the exponents when you're multiplying them. Now, what happens when the exponents are negative? Well, we actually saw this last time. If I wanted to do this out, I would get 5 to the third, right, times 5 to the negative 2. Well, that's going to be 5 to the third over 5 squared, right? So this is going to be 5 times 5 times 5 over 5 times 5. And you can see these all cancel out, and all I am left with is 5. Okay? Can we use this addition to do the same thing? And the answer is yes, we can, right? 5 to the third times 5 to the negative 2 is equal to 5 to the 3 plus a negative 2, and 5 to the 3 plus negative 2 is 5 to the first power, or just 5. So either way, we get the same thing. So can we use this rule when we are doing this? And yeah, doesn't matter if your exponents are positive or negative. Just use the rule and then evaluate the exponents at the end. Okay, so here's another one. We have b to the negative 5 times b to the negative 2. This is going to be equal to b to the negative 5 plus a negative 2. And that comes out to b to the negative 7, which is actually 1 over b to the 7th power. Okay? Hopefully that makes sense. Review that. If that doesn't, make sure you understand it, but it is a really simple concept. Okay? Now, what happens when we're multiplying powers in algebraic expressions. This is actually going to be pretty important, because when we start talking about polynomials, this is essentially what we're going to be doing. When multiplying algebraic expressions with constants, separate the constants. Remember, unless the base is surrounded by parentheses, the exponent only modifies the value it is attached. So in this case, this x to the 6, this 6 only affects that x, and this 7 only affects this x. So basically, what do we have here? We have 2 times x to the 6 times 4 times x to the 7th. And so what we can do is we can move stuff around because we're multiplying, commutative property of multiplication. 2 times 4 times x to the 6th times x to the 7th, right? We know how to deal with the numbers. That's going to be 8. X to the 6 times x to the 7 is going to be x to the 6 plus 7, which is going to be 8 times x to the 13th. So here is our answer. So essentially what you're doing is you're just multiplying the coefficients together, and then you're working out the part with the variables. Okay? Let's take a look at this one. This is going to be 2 times y to the 8th times 5y to the y third, y to the third, or y cubed, times 7y to the negative 5th. So again, we can move all the coefficients together. That's going to be 2 times 5 times 7, and then this is going to be y to the 8th times y to the third times y to the negative 5th. And I'm going to ask you if you remember, can you add more than two numbers together at the same time? And the answer is yes. 2 times 5 to the 7th is going to be 70 times, this is going to be y to the 8 plus 3 plus a negative 5. So 8 plus 3 is 11, plus a negative 5 is going to be 6. So this is going to be 70 y to the 6th. Okay? Hopefully that makes sense. Please review that, but essentially all we're doing is we're multiplying the coefficients together, and then we're working out the exponents just like we did above. Okay? All right, let's move on. Now, if you guys remember, there's something called scientific notation. Scientific notation is a way of writing really, really big numbers or really, really small numbers. For example, instead of writing 5,200,000, 5,200,000. Sorry, that was okay. So 5,200,000. I can rewrite this as 5.2 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6. Okay? Times 10 to the 6. And if you actually work that out, 5.2 times 10 to the 6, that comes out to 5,200,000. All right? So it is an alternate way of writing really, really, really big numbers or really, really, really small numbers. We take it as a decimal times a power of 10. So that's scientific notation. Well, look, here's scientific notation here. 7 times 10 squared times 4 times 10 to the 5th. We're going to use what we previously learned, right? These are 7 and 4 are just coefficients, so we can say 7 times 4 times 10 squared times 10 to the 5th. So that is going to be 28 times 10 to the 2 plus 5, which comes out to 28 times 10 times, times, I forgot that multiply, times 10 to the 7th. Okay? So what is 28 times 10 to the 7th? That is going to be 28 with 10 to the 7th means there are 7 zeros at the end. 1, 2, 3, 4, 5, 6, 7. Or you are going to move the decimal place 7 places from where it's at. Okay? 7 places from where it's at. Hopefully that makes sense. Okay. All right. Now, can we write this in scientific notation? Yeah, actually. This is going to be 228 times 10 to the 7th right? We're going to rewrite this in scientific notation because sometimes we want the actual number, but sometimes it's convenient to just write this in scientific notation. Let's look at this. This is actually 2.8 times 10 to the first, right? And then we're going to multiply this by 10 to the 7th. And why is that? Because if we take 2.8 and we add, or we move it one decimal place, right? Because 10 to the first means we're moving it one decimal place to the right, we get 28. So those are equivalent. So if we work this out, again, we use our rules again. This is going to be 2.8 times 10 to the 1 plus 7, or 2.8 times 10 to the 8th. Okay? All right, so hopefully that makes sense. Please make sure you understand this, and let's see if you have any questions, make sure you ask, okay? Try these practice problems 1 through 6. Go ahead and hit pause and work on these, and then when you are ready, unpause them and see if you got the same answers as I did, okay? So go ahead and hit pause. Okay, so hopefully you got all of these. Let's take a look at this. Well, this one's going to be pretty easy. This is going to be 3 to the 3 plus 6, which is 3 to the 9th. Okay? And if the instructions say leave as a positive exponent, then this is fine. You don't have to necessarily work that out. Okay? This is going to be 2 to the 4th times 2 to the negative third, 4 plus a negative 3. We're going to add the exponents. Remember, this is going to be 2 to the first, which is actually just 2. All right, here we have n squared times n cubed times 7n. Remember, if there's no exponent, we actually know there is an exponent. We don't write it. It is to the first power. So this is going to be 7 times n squared times n cubed times n to the first power, which is 7 times n to the 2 plus 3 plus 1, or 7 n to the 6th power. All right, and here we're going to separate out the coefficients. This is going to be 3 times 7 times m squared times m to the negative 2 times m to the first power, or 21 times m to the 2 plus a negative 2 plus 1, or 21 m to the first power, which is 21m. Okay? All right, let's take a look at the scientific notation ones. Remember, we can rewrite this as 2.5 times 10 to the 8th times 6 times 10 cubed. So this is going to be 2.5, these are the coefficients essentially, times 6 times 10 to the 8th times 10 cubed. 2.5 times 6 is equal to 15. This is going to be 15 times 10 to the 8 plus 3, or 15 times 10 to the 11th. But if we're going to write this in scientific notation, we need to rewrite 1.15. Remember, in scientific notation, in scientific notation, right? First number is always in ones digit. So the first number is always in the ones digit, so we need to put a decimal point after the 1, or the first number. In this case, it's 1. So we're going to rewrite this 1.5. Well, what do I have to multiply 1.5 by to get to 15? That's going to be times 10 to the first power, and then times 10 to the 11th power. So this part here is going to be the same as this thing. Okay? So that becomes 1.5 times 10 to the 12th power. All right, and lastly, we're going to do the same thing here. This is going to be 9 times 10 to the negative 6 times 7 times 10 to the negative 9, and we get 9 times 7 is equal to 10 to the negative 6 times 10 to the negative 9, or 63. Oops, I don't know where that equal sign came from. Sorry about that. 63 times 10 to the negative 6 plus negative 9, right? And this is going to be 63 times 10 to the negative 15. Now, scientific notation is one of the few places where it is okay to have a negative exponent. Okay, so one of the few times where negative exponents are okay. So if you are taking the 10 to a negative 15, that means you are moving the decimal point 15 places to the left. That's what the negative means, because you're dividing by that 10 to the 15. Remember, because 10 to the negative 15 is equal to 1 over 10 to the positive 15. So if we multiply that by 6.3, you're essentially dividing by 10 to the 15, okay? Or 63, right? So you're moving that 15 places to the right. But remember, in order to make the scientific notation, we can't have 63. We want this 6.3. And how do we get that? That is going to be 6.3 times 10 to the first power times 10 to the negative 15. And if we do that, that is 6.3 times 10 to the 1 plus a negative 15 is going to be negative 14. So that is what that's going to be, 6.3 times 10 to the negative 14. Okay? Hopefully that makes sense. Please review this. Make sure you understand it. If you have questions, please ask. Okay? Thanks for listening, and I will catch you guys later.